Hello, now another question on graphical method of solving a pair of linear equation in two variables. Okay. So is the question, solve graphically the given pair of linear equations in two variables, this one and this one. And also you have to find the coordinates of the vertices of the triangle formed by these two lines and the x-axis. So first we have to plot the graphs of the two equations. So let me take the first equation 1. What is that? If I write in this equation in terms of y, so y I take to the other side, y will positive, and what is left? X plus 1. This is the equation I have written to get the table for plotting the graphs. So if I take x to be 0, y will be 1. If I take x to be 1, then y will be 2, and if I take x to be 2, it will be 3. So I can now plot the first line. Now for the second line, this is the second line. So what is 2y? 2y is equal to, 2y is what? These two will go to the other side. So this will become plus, this will become minus. So 12 minus 3x. 12 minus 3x. Or y will be, if I divide by 2, so this will be your y. Okay, I have expressed y in terms of x. Then I get the corresponding table x, y. If x is 0, then 12 by 2, 6. So x is 0, it will be 6. If x is 1, 12 minus 3 is 9, so it will be a fraction, so don't take 1, you take 2. 3 to the 6, 12 minus 6 is 6, so I can take 2. Then 3 to the 6, 12 minus 6 is 6, and 6 by 2 is 3. And then let me take 4. The 3 4s are 12, so 12 minus 12 will be 0. So let me take 4. X 4, then it will be 0. So in this way, you can very easily get the table. Once you express y in terms of x, by visualizing or observing, you can choose the values of x so that you get integral values of y. So now we will be plotting them on the graph paper. So in the graph paper, you see here all are positive. Okay, anyway, so let me draw the graphs. So this is your, say, y-axis, and here let me draw the x-axis. Mutually perpendicular lines, and the point of intersection is the origin, whose coordinate is 0, 0. Actually, you know, these are the reference lines on the Cartesian planes. The distance from the y-axis is known, the x-coordinate or abscissa of a point, and distance from the x-axis, how above or below the x-axis, gives you the y-coordinate or ordinate. So first equation, 0 when x 0, y is 1. So when x is 0, y is 1. So let me first scale the things, because we will be doing in graph paper, it will be easy for you, but I have to sketch here, so I have to approximately, let me see, the maximum value of x is 4. So let me take, say this way, 1, 2, 3, 4. Okay. Oh, sorry, just a minute, it was x values, no? Okay, no problem, because y has 6, so okay, I have to change it. It was 4. Okay. Let me plot in this way first. X, maximum values of x is 4, so in this way, 1, 2, 3, 4, etc. And here, let me take in this way, and this will be, say, 6. So the middle is, say, 3. So 1, 2, 4, 5. So in this way I have marked the numbers on the two axes. So the first one 0, 1, 0, 1. This is the point. Next is 1, 2. So is 1 here and this 2 here. This is the next point. Third point 2, 3. 2 here, 2, and you go up to 3. Third point here it is. So 2, 3. So these are the 3 points. I will join with the help of a scale with the help of a scale I have to join to get the graph. Extend both way. Always you have to extend both way when you plot a graph. And this point will be -1, -2 in this way. So this is the graph of the first equation. I can write in this way: x minus y plus 1 is equal to 0. The first equation. Now let me plot the second one. 0, 6. 0 and 6 here. So this is the point 0, 6. Next point 2, 3. 2, 3 the same point. This is your 2, 3. Then lastly 4, 0. So it is 4 and 0 and here 4, 0. So I have to join this line, these 3 points together approximately like this. It should be with the help of a scale. If you draw, it will be a straight line, perfect straight line. So this is your second equation, this is your first equation, and this is your second equation. Or you can write the equation along the line also. 3x plus 2y in this way. 3x plus 2y minus 12 is equal to 0. So this is the point of intersection. So therefore required solutions are x is equal to 2 and y is equal to 3. So from the graph I am getting the solution. That is the point of intersection of the two lines gives us the solution. Okay, the first part done. This solve is done. Next, to find the coordinate of the vertices of the triangle formed by the lines and the x-axis. So this is one line, this is another line, and this is x-axis. So this is the triangle. So give a name, say this is say A, and this point will be B, and this point is C. So the coordinates of the triangle, so triangle is your ABC, is the required triangle. ABC I have shaded. Now I have to find the coordinates of the vertices. So for the first vertex A, what is the coordinate? It is 2, 3. 2, 3. For the second vertex, I have taken this to be B, so it is -1, 0. And the third vertex is 4, 0. So these are the vertices. Answer. Okay. Actually, this line is not looking straight. If you draw with the help of a scale, then it will look straight. Okay, something like that. Okay, so we'll be writing the equations along the line. Okay, and then you can read out the vertices. And if you have to find the area of this triangle, we can very easily find. Is an extra I am doing. Area of the triangle ABC will be half base is your BC into altitude. This is the altitude, and this is nothing equal to this 3 unit. So it is 3 unit. And what is BC? This length is BC. This is the base BC. So here I am taking 1 unit from here and 4 unit from here. 4 and here 1. So 1 plus 4, it is 5. So it is 15 by 2, that is 7.5 square unit is the area of this triangle. Okay, so in this way we solve graphically means you have to find the values of x and the variables which I get from the coordinate of the point of intersection of the two lines. Okay. Okay. Now let's see some more questions. Now another question on graphs. Draw the graph of the equations these and this one, and then you have to find the area of the quadrilateral formed by these equations and the x-axis. So you see what are the equations here? Let me see. X is equal to 3. This is not a linear equation, 2 variable, there is only 1 variable. And you know x is equal to 3 means x is 3 for all values of y. and x is equal to 5 also. This is also an equation in one variable, and that means also x is 5 for all values of y. So these and only this one is the linear equation in two variables. 2x minus y minus 4 is equal to 0. This is the linear equation in two variables. So we have to plot the graphs. So now let me write in this way. Y is equal to, take y to the other side, becomes plus, so 2x minus 4. So we can make the table x, y. So when x is 2, 2 2s are 4, 4 minus 4 0, so I take 2, so it will be 0. Now you see, I have to plot x is equal to 3. So I should take a value for 3, that is 3. So what is 3? 3 to the 6, 6 minus 4 is 2. Next, x is equal to 5 I have to take. So 5 2s are 10, 10 minus 4 is 6. So now we have to draw the graphs. Okay. So let me take the coordinate axis, x-axis, the horizontal one, and y-axis, the vertical one, and this is the origin 0 0. So first this let me plot this on 2 0. So let me again scale them. Maximum value 2 3 5. So let me take in this way. 1 2 3 4 then 5. And what are the values of y? Is up to 6. Okay. So here say this is a 6. So this is your 3, middle one, then 1 2 4 5. In this way I am scaled the axis. So let me plot this one first. 2 0. This is 2 0. This is the point. Then 3 2 3 here and here 2. So this is the point. 3 2 is here. 3 2. Then 5 6. 5 6 is here. It is somewhere here. So when I join this with the help of a scale, okay, something like that. So this is the graph of the equation, this one. Twice x minus y minus 4 is equal to 0. Next I have to plot x is equal to 3 for all values of y. That means for all values of y x is 3. So it will be a vertical line goes through this. It will be a line parallel to the y-axis because x is constant. This x is constant, which is equal to 3. For all values of y, x is constant. So it is a parallel. Similarly, x is 5 will be another line parallel to y-axis through 5. X is 5. Draw a line parallel to y-axis. Okay. So this is your x is equal to 3 and this line is x is equal to 5. Okay. So these two lines are parallel to y-axis and perpendicular to x-axis. And this is the equation line of the graph of the linear equation two variable. So you see what you have to find now. The area of the quadrilateral formed by the line. So this is one line, this is another line, and this is the linear equation two variable, and this is x-axis. So this is the area. So the quadrilaterals give us name A, B, C, D. So ABCD is the required quadrilateral. ABCD is the required quadrilateral. Now since AB is parallel to CD, therefore ABCD is a trapezium. And we know the formula of area of a trapezium. What is that? Area of a trapezium is half its altitude into sum of its parallel sides. This is the formula, you know. So I can write, so area of, therefore this you have to find the area of the quadrilateral, that means area of this trapezium. So area of ABCD is equal to half. What is the altitude? Altitude is your BC, and parallel sides AB plus CD. AB plus CD. So now simply put the values. What is BC? BC, this is yours. What is this? Coordinate of C is your, this is 5, no? 5, 0. So this distance is 5 and this distance is 3. So 5 minus, this is your 5 minus 3, that is 2. So it is 2. What is AB? AB is this 2. AB is 2 unit. So AB is 2. And what is CD? CD is your, it was, just a minute, 5, 6, it should be some, yeah. So it will be 5, 6, actually let me take the point here, 5, 6, so this length is your 6 unit, so it is 6, due to getting cancelled, so it is 8 square unit is the answer. Okay, now I will discuss about the conditions of solvability, a pair of linear equations in two variables. Now you see, now we have seen that the pair of linear equation, when they are represented as a graphs, so we get a solution from their common point of intersection. So it may be like that if the two graphs of the two equations, suppose say, is a Cartesian plane. So if the graphs intersect, then easily we can get the solutions. But if the graphs don't intersect, if the graphs are like this, suppose parallel, if these are the two equations, then they will never meet. So then when the graphs are parallel, then there will be no solutions because they will never intersect. And if the two graphs, two lines coincide on each other, that is both the lines on the same line, then all the points are their point of intersections, that is all infinite many points will be their solutions, common solutions. That means in that case these pair of linear equations will have infinite many solutions. So from these basic concepts we can say that when lines intersect, 1 and 2, let me say 1 and 2 intersects, what we get? We get a unique solution. That is the point of intersection of the lines, unique solution. And when the lines does not intersect, that is the parallel, since no point of intersection, then there will be no solution. And when they are coincident, that is they superimpose on each other, coincident, all the points of solution, so there will be infinite many solutions. Infinite many solutions. Okay. So when the pair of linear equations have solution, then we say that this system of equations or the pair of linear equations is consistent, means they have solution is consistent. So in this case, this is consistent. also in this case, when it is infinite many solution, then also it is consistent. But in this case, it will be inconsistent. Inconsistent. And also when the pair of linear equations have infinite many solutions, we said that the pair of equations are linearly dependent. That is, we say linearly dependent. Okay. So now these things are possible to know only when you plot the graphs. Now without plotting the graphs, it is whether it will be possible to know about their condition of solvability. That is, whether it will have unique solution, or it will have infinite many solution, or it will have no solution. That is also possible. How it is, I show you. For that you have to know some basic thing. So in the plane, suppose I have a line is plotted, a linear equation in two variables. So it is ax plus by plus c is equal to 0. Any line is plotted. Then this line makes an angle with the x-axis. So this is known as the inclination of this line with the x-axis. So if the lines are parallel, suppose I draw, then what will happen? This angle has to be same. By the corresponding angles are equal, you know. So if the lines have to intersect, then obviously this angle have to be different. So when this angle is different, suppose I take an intersecting line, say this is, so in this case this is the, so these two are not equal. So you see that in case when the line intersects, the slopes or the inclination of the lines have to be different. So in this case slopes has to be different, and in these two cases the lines has to be parallel, or if they are coincident on the same, the angle will be same. So in this way I can differentiate. So the first case, case 1, when lines intersect, what will happen? Slopes or the inclination to the x-axis, or that is known as slopes, slopes will be same. Slopes will be different. Slopes will be different. Slopes means the inclination of the lines with the x-axis. They have to be different, then only they will intersect. As you see, two lines intersect only when this is one slope and this is slope. So they are different, then only they will intersect. So now the slope of the lines are generally ratio of this a1 by b1. So a1 by b1 is the slope of the first line, and a2 by b2 is the slope of the second line. So they cannot be equal. Or if I rewrite in this way, that is, if I interchange these two, same thing, a1 by a2 is not equal to b1 by b2. Because if a1 b2 is equal to okay, so in the same. So this is the condition to be satisfied when two lines will intersect. So if I know the equations, I know the coefficients, I know these values, so I can check whether these two ratios are equal or not. If the ratios are not equal, then I can conclude that the lines will intersect, so I will be getting a unique solution and the system of equations will be consistent. And in these two cases, equal slope, because for parallel lines as well as for coincident lines, slope has to be same. So in these two cases they will be equal. So case 2, a1 by a2 is equal to b1 by b2. Now you see slopes same, but they may be parallel, may be coincident. So how will I differ these two? You see, again let me come to the graph. This is a line, then this is, I have told, the slope, that is a1 by b1. But what about this? This is known as the intercept, which is your c1 by b1. Okay, so this is for the line, say a1x plus b1y plus c1 is equal to 0. This will be slope. For another line, this will be the intercept on the y-axis, this will be c2. So when they are parallel, c1 by c2 will be different. And if they are coincident, then these intercepts will become same. So when they are parallel, I can write the ratio of the intercepts has to be also same. So in that case, this will be coincident lines. Because intercepts also same, coincident lines, which will give you infinite many solutions. Infinite many solutions. And the third case, slopes are same, but the intercepts are different. That means they are parallel lines, which means no solution. That means the system is inconsistent. So these are the condition of solvability. The first of a unique solution. This is for infinite many solution, and this is for no solution. For example, let me take an example. So let me give a, say 2x plus 3y is equal to say 11, and say 3x plus y is equal to 7. If I take this pair of linear, so obviously what is a1 is this 2 and a2 is 3. So first you check what is a1 by a2. Coefficient of x in the first equation 2 and coefficient of x in the second equation 3. Then I have to check whether a1 by a2 is equal to b1 by b2. So what is b1 by b2? b1 is the coefficient of y in the first equation, that is your 3, and b2 is coefficient of y in the second equation, that is 1. So obviously these two are not equal. So a1 by a2 is not equal to b1 by b2, as 2 by 3 is not equal to 3. So we come to this conclusion that because this condition is satisfied, so this system of linear equation will have a unique solution. That means they will intersect at some point. Now let me take another. In this case, a by 2, 2 by 3, and what is b1 by b2? 4 by 6. 4 by 6, which is also 2 by 3. So in this case, a1 by a2 is equal to b1 by b2. So now I have to look for the third ratio, c1 by c2. What is c1 is 8 and c2 is 7. So c1 by c2 is 8 by 7. So this is not equal to, so this is the third case, that is a1 by a2 is equal to b1 by b2 but not equal to c1 by c2. So I can conclude that the lines will be parallel. These two lines will be parallel. They will not never intersect, so they will have no solution. So system of equation is inconsistent. And suppose if this is like this, okay, like this. Then what will be c1 by c2? Then c1 by c2 will be 8 by 12. Then again it is 2 by 3. So in this case, all the three ratios are equal. Then this condition is satisfied. So then we can say that these two lines will be coincident lines. So it will have infinite many solutions. So without plotting the graphs, just looking at the coefficient values, the ratio of the coefficients, and checking this condition, we will be able to say about the nature of solutions, whether it will be consistent or inconsistent, and if it is consistent, whether it will have unique solution or infinite many solution. Okay, so that's all about graphical methods of solutions of a pair of linear equations, two variable. So you can practice more questions of this type. Okay, in the next video I'll be solving the method of algebraic method. Okay.